So the next topic that we are going to discuss is electric field due to a dipole at equatorial point, right? Electric field due to a dipole at equatorial point. So if I take the system of dipole, that is a positive and a negative charge, first we need to understand what an equatorial point means. For that, observe. If I take this to be the dipole, positive charge, negative charge, right? If I am able to define an axis in this way, right? If I am able to define an, sorry, if I am able to cut a plane, right? My hand is a plane, a two-dimensional shape. If I am able to cut a plane through the axis of it and perpendicular to the axis, then you will call the plane as equatorial plane, right? For that equatorial plane, right, if you have to visualize, no, suppose the equatorial plane is looking something like this. Okay, I kept it like this, no. Yeah, so the equatorial plane is looking something like this will be called as the equatorial axis. So on the equatorial axis, if you take any point, then that point is what is called as equatorial point. So are you able to understand? So this is the dipole. If the dipole is like this, I am cutting a plane which is perpendicular to the axis of the dipole, and then this plane is called as the equatorial plane. On this equatorial plane, if you draw an imaginary line which is passing through the center of this dipole, you call it as the equatorial axis. Any point on that equatorial axis will be called as the equatorial point. Now our job is finding the value of electric field at that equatorial point. So when I draw it in two-dimensional shape, I'm not going to draw the plane and everything. I'll just directly draw the axis and I will take a point on top of it. So how is that axis going to pass through? It is going to pass through the center of the dipole. Am I clear with this? So if I take this to be O, this is the point P where we are interested to calculate the electric field, right? So here it is Q, here also it is Q in terms of magnitude. Now the question is very simple. Due to this positive charge, what is the direction of electric field here? Is it away or towards? It is away because it's a positive charge. So join these 2 points and extend it, draw an arrow mark like this, and you call this as the electric field due to the charge at point A. Similarly, due to this charge from point P joined to this, what is going to be the direction? Obviously, towards. So, this is going to be EB. Make sense? Right. Now, if I take the distance from the center to this point as R, this is broken into two equal parts where this part is going to be A and this part is also going to be A. This is R, this is A. So from the right angle triangle, this is going to be root of R square plus A square. In a similar way, this is also going to be root of R square plus A square. Right? Having said this, if I take the electric field due to the charge at point A, what is it going to be? It will be Q divided by 4 pi epsilon naught into distance square. So what is the distance square? This is the distance root of R square plus A square, the whole square. So what will happen? Square root and the whole square will get cancelled. So you will be left out with R square plus A square. So unlike the previous case, I am not putting the direction here because it is not completely aligned along the direction of dipole moment. It is randomly oriented. Right? So it is going to be R square plus A square. Similarly, the electric field at point P due to the charge at B is going to be Q. I am taking the magnitude alone because I have already taken the direction in the arrow mark form. So Q divided by 4 pi epsilon naught into root of R square plus A square the whole square, which is again going to be R square plus A square, simple. Right? If you observe the magnitude of both, they are exactly the same. So electric field at A is equal to the electric field at B. I'll call it as E. Right? Let me call it as E for the time being. So if I take this point P, one electric field is like this and the other electric field is like this. And we know that when we have two coinitial vectors, we need to take the resultant where we apply the parallelogram law of vectors. So where is the resultant going to be? It will be a diagonal. And we also know the fact that when we have two vectors of equal magnitude, the resultant will be a angular bisector. Means if I take the angle between them, let's say for example to be alpha, right? Then this resultant electric field is going to be alpha by 2 and this will also be alpha by 2. Simple. Right. Now what I'm going to do is, since these directions are not oriented along the dipole moment, I'm going to break it into their components. But before that, let's see one thing. If I take this to be alpha, for instance, right? So if I take this to be theta, then how much will this be? This will also be theta because they form an isosceles triangle. The base angles are going to be same. And with respect to alpha, these are the opposite angles. So we know that exterior angle is equal to sum of the opposite interior angles. So if I say alpha, alpha will be equal to 2 theta. It's very simple. Alpha is equal to theta plus theta, 2 theta. So what is alpha by 2 here? It is basically theta and this is also going to be theta. Meaning the resultant is drawn here, right? The resultant which is drawn here will actually be parallel to the base itself. Only then this angle can be theta. It forms corresponding angles, right? And here the angle will be theta, which is the alternate interior angles. Make sense? Right? So having said this, in the same diagram, if you observe, if I resolve them into two components, if this is theta, then this is going to be E cos theta, and due to this electric field, this will also be E cos theta. Now downward will be E sin theta and upward will also be E sin theta. If you observe, E sin theta gets cancelled. So what gets added? E cos theta gets added to E cos theta. So if I write the value of ER, okay, let me call it as EP. So electric field at point P is equal to, it's going to be E cos theta plus E cos theta. This is not principle of superposition, rather we are adding the vectors in that direction. So that's why I'm not putting an arrow mark on top of it, right? So I can write this as 2 times E cos theta, which is equal to 2 into, what is the value of E? Q divided by 4 pi epsilon naught R square plus A square multiplied with, what is the value of cos theta from this triangle? If I take this to be AB, if I take the right angle triangle POB, this is going to be theta, this is A, this is root of R square plus A square. Simple. So what is the value of cos theta? Base divided by hypotenuse. So it's going to be A divided by square root of, one minute, square root of R square plus A square. Now it's very simple. So 2 into Q into A is dipole moment divided by 4 pi epsilon naught into R square plus A square multiplied with R square plus A square to the power half. So A square into A power half will be A power 3 by 2. So here it will be R square plus A square the whole power 3 by 2. But we know the approximation. What is it? We know that R is very much greater than A, which implies R square plus A square is also approximated to R square. So R square plus A square is approximated to R square. So R square is left inside. R square to the power of 3 by 2 is R square to the power 3 by 2. 2 and 2 will get cancelled. You will be left out with R cube. So what will be the answer? It will be P divided by 4 pi epsilon naught R cube. And now if I write the same value as, I mean, if I replace EP with E equatorial, they both mean the same. So if I write it as a vector quantity, then it will be P divided by 4 pi epsilon naught R cube. Now look at the direction. Dipole moment is in the leftward direction and electric field is in the rightward direction. So this will be minus of P cap, meaning the electric field due to a dipole at equatorial point is always in the direction opposite to the dipole moment. It is always in the direction opposite to the dipole moment. So E equatorial is always in direction opposite to the dipole moment. And if you look at the magnitude of this is exactly the half of what we saw in the previous case. In the previous case, it was 2p divided by 4 pi epsilon naught r cube, whereas here it is p divided by 4 pi epsilon naught r cube. Having said this, what we can conclude is electric field due to axial, the magnitude of this is always twice the electric field due to the equatorial. Are you able to understand? So this is how the electric field due to a dipole is calculated at two important points. What are they? One is the axial and the equatorial point. Am I clear with this?